All right, now that we've looked at the square root function, we're going to look at the cube root function and cube roots in general. Now, these functions are actually counterparts of squaring function and cubing function, right? And what does a squaring function do? It multiplies a number or an object with itself twice. And a cubing function does the same but 3 times, right? So, which means that finding cube roots now is actually finding 3 copies of the same thing. Okay, so how we write that is, we use the same symbol, but we add a 3 over here to mean this 3 indicates it is cube root. And so for example, cube root of 16 is going to become cube root of 2 times 2 times 2 times 2. There are 3 copies of 2, so one of the 2 goes out, but there is a single 2 that remains inside. Whereas if it was, say, 27, then the cube root of 3 times 3 times 3 is, there's exactly 3 copies and all 3 go outside and there's nothing left inside, so it becomes 3. Now remember when we did addition and subtraction of cubes, there were some numbers that until the cube of 5 you should know, right? So if you know 5 cube, right, the fact that 5 cube is 125 is the same as saying that the cube root of 125 is 5, right? Because what is the cube root asking? The question it's asking is, what is the number that I multiply 3 times to get what is inside the cube? Let's look at some similar examples here. You're given a function, you're asked to evaluate. So f of 127 becomes cube root of 127 minus 2, which is cube root of 125, which is cube root of 5 times 5 times 5. With 3 copies, this comes out to be 5. Similarly here, g of negative 7, cube root of 8 times negative 7 minus 8, cube root of negative 56 minus 8, cube root of negative 64. Now how do I get negative 64? To get negative 64, I take negative 4 times negative 4 times negative 4. Okay? Now think about it a little bit. Negative 4 times negative 4 becomes positive 16, but then 16 times negative 4 becomes negative 64. And there's 3 copies of negative 4, so this is negative 4. So this example shows that you can take cube root of negative numbers, right? So we already see a fundamental difference between a cube root and a square root function. We can take cube roots of negative numbers because when you multiply a negative number 3 times, it remains negative. Okay, so, and this is not special to the numbers 2 and 3. This happens because 2 is even and 3 is odd. Right, so for example, if I'm taking the 4th root of 81, right, I'm looking for 4 copies. So that's 3 times 3 times 3 times 3, and that comes out to be 3. If I put a negative outside, then that's just negative 3. This is not defined. But the 5th root of negative 35 is okay because negative 32 is negative 2 times negative 2 times negative 2 times negative 2. So there's 5 copies, so it is negative 2. So basically the conclusion is, if even root, only positive numbers allowed. If odd root, then both positive and negative numbers allowed. So how we express that result is that we say if you take so this would read as nth root, yeah? So for square, we have a special name. For cube, we have a special name. But after that, we just start saying 4th, 5th, 6th, 7th, 8th, 9th, etc. Nth root of a to the power n, they cancel each other out, but you have to be careful about the case where you're dealing with n even or n odd. If n is even, this comes out to be the absolute value of a, which means it's always positive. And if n is odd, then it just comes out to be a. Okay, so this bit is important. Like, see, applied here. 4th root of 81, 81 is positive, so it comes out to 3. Right? 5th root of negative 32 comes out to be negative 2. So it can be positive, or it can also be negative. Okay, so that's the end of this discussion about square roots and cube roots. Next, we're going to look at another representation of these square roots, right? Because these symbols, the radical symbols, are new. We want to be able to write them as exponents so that we have a more standardized notation for like x squared and also for square root of x. And we will see that we can actually write these as exponents and then apply properties of exponents to make things easier. That's it for this video. Thank you.